Hello, chemistry. Miss E back to try and help you out with some mole conversions and come up with step-by-step processes, or come up with a step-by-step process in order to figure out these types of conversion problems and how to set them up. Okay? So first of all, let's look at what your problems reads. This one reads, how many atoms are in 5 moles of calcium? Okay, so after you read it, the first thing you need to do, or want to do, is recognize the important parts of this here problem. So you can either do that mentally, or something I do is just underline what's important. So for me, atoms seems important. 5 moles seems important. And calcium seems important to me. Okay? The second thing you want to do after that is you want to take a look at what you need to find in, like, what is this question asking you to find? Okay? So this question is asking you how many atoms are there. So how many atoms? So this is what we're looking for as our answer. So is atoms. Okay. Next thing you want to do is recognize what you're given. So if we look at here, how many atoms are in 5 moles of calcium? You are given 5 moles of calcium. So this is what we're given, and this is what we need. Given. Okay. Next thing you want to do is think of relationships between the things you have and the things you need to find. So for instance, what's the relationship of moles and atoms? And what's the relationship between calcium and moles? Because if you think calcium is important, you got to think about that. And how is calcium related to atoms? Okay. Third thing you want to do is try and figure out, or recognize, conversion factors or conversion things based on the relationships that you've noticed. Okay, so for instance, what do we know is the relationship between atoms and moles? Hopefully you should immediately say that 1 mole is equal to 6.022 times 10 to the 23rd parts pieces. In this case of atoms, it's atoms. Could be molecules if you are looking for molecules of something, but in this case, it's atoms. Okay, so we know that for a fact. And then something else you might know or want to find out is the molar mass of calcium, just in case. But then you also have to say, well, do I need to go that far? Because if you're looking for the molar mass of calcium, I mean, you could look that up on the periodic table. And if we find calcium on here, it's over here. The molar mass is 40. But then you need to put your units on there, which is grams per mole. And then you have to, once you write down those, you have to figure out which of these conversion factors you need. If you need both, one, what do you need, one or the other or both? Okay. So once you write down your conversion factors, now you have to write a conversion equation to get what you need. So you go from what you're given to what you need. So first off, you write down what you're given. So you have 5 moles. And since it's not moles over something, it's just going to be a whole number of 5 moles on the top of your conversion equation over 1, because 1 means that it is a whole number. Okay, there's no units under here, it's just 5 moles. Okay. And then obviously the conversion equation has at least one of these like extra, pieces to it to get from what you have to what you need. And what you need at the end is atoms. Okay? And this is something we want to get rid of, right? Because we're going from moles, which we start with, and we're going to be ending with atoms. So we should try and be using a conversion factor that gets us there as soon as possible. Okay? So we need to have moles in our conversion factor over here. And we also want to try and see if there's something that has atoms in it as well. If we look at our 2 conversion factors we have here, this has mole in it, and it has atoms in it too. This one down here has grams in it and moles. It doesn't have both. It has grams, which it doesn't even talk about up here us wanting. So I don't think we need this conversion factor in our equation down here. This one has both, which is ideal. So we're going to take that down here, put moles kitty corner, because if we remember, if one is on the top, in order to get rid of it, it has to be on the bottom in the next one. So here, 1 mole goes down here. So 1 mole is 6.022 times 10 to the 23rd. Atoms, our moles are going to cancel out. And notice the one we have here left is atoms, which will go to the end of your answer. All you need to do is then, after you get this written and go, I have all that I need, like I have the units I need, and I have everything, like I have the conversion factors I need to get to the unit I need. And knowing that this unit is on top means it's also going to stay on top. Okay? Which is where we want it to be. So once we have your conversion equation set, all you have to do from here is solve. And remember, with conversions, all you have to do is take your top and multiply by the stuff on the top and divide by stuff on the bottom. If there's ones, then it's just over, like it's just a whole number, and you don't have to figure that out. Okay, so I'm going to load up Desmos here. So we got 6.022 times 10 to the 23rd. And we're going to take that and times it by 5. And I forgot Desmos does not let me do that. Times 5. And we get the number 3.011 times 10 to the 24th. I'm just going to round it to 3.0 times 10 to the 24th. Once you get this answer, go back and read your question to make sure that you have what you're looking for. So again, this one was looking for how many atoms are in 5 moles of calcium. Is our answer in atoms what we need to find? Yes, it is. That means you're good to go. You found out how many atoms are there in 5 moles of calcium. Notice we didn't use the molar mass of calcium. In this instance, this didn't matter what it was. You could replace this word with any of the other elements in the periodic table, or any molecule for that matter, as long as this changed to molecules as well. It doesn't matter, because atoms and moles are what you're concentrated on. Nothing with grams or how heavy it is. It was just concentrating on how many moles there were and how many atoms. Okay? So let's try another one. Here we have one that says calculate the mass of 3.47 times 10 to the 23rd gold atoms. Okay. Number one. What is important? What's important? We have the word mass. That seems important. This here number also seems important, and we have to make sure that we understand that it's gold atoms. Okay, so these things seem important. Second, what do you need? Calculate the mass. We need to find this. Okay? Since you need to find a mass, hopefully when you hear mass, you should also think of the unit that you need. So you should hopefully be answering this in things like grams. Okay? Or if it says so in your problem, you should be answering in that form of mass. Okay? 3. What do you have, or what are you given? You're given a number. You have this many gold atoms. Okay? Okay, so we have that many atoms of gold. Number 4. Look at the relationship between the stuff you need and the stuff you have. So we have mass here, and we have gold atoms. Right off the bat, we don't know specifically how they're connected, other than we know gold itself has a certain mass. It has a certain mass to it, and we can find that in a second. 5. Write your conversion factors. Conversion factors. We have mass, and we know that gold has a certain mass, so we should try and find the molar mass of gold. Here, I'll write my conversion factors. So if we look at our periodic table, we find gold, which is down here. We see that gold has a molar mass of 197. So we write that down, 197, and that's grams per mole. Okay? Or better written as 97 grams per mole. Okay? Either way you can write it. So if we know that about gold, another conversion hopefully you should realize that you should have, if we see mole, oh hey, we got this big number again. Maybe we should be finding out how many moles this is. So write your conversion factor that you have 1 mole that equals 6.022 times 10 to the 23rd. And we have atoms, so it's going to be in atoms. Okay? So we've addressed our mass thing, we've addressed our gold thing, and we've addressed our atoms thing in our conversion factors, which is good. That's what you should do. You should try and address all the things here and like try and connect with your relationships as well. 6. Conversion equation. Write it out. First, by writing down what you have first, like what you've been given. So write down 3.47 times 10 to the 23rd. Atoms. Okay? You could even say gold atoms if you want. Over 1. From here, you should be thinking, I have to get rid of gold atoms in order to move on in my conversion. So your conversion, one conversion factor has to go here. And look at that. We got to get rid of gold atoms, and we know that this many gold atoms makes up 1 mole. So let's use that. So gold atoms has to be on the bottom, so we write the 6.022 times 10 to the 23rd. Gold atoms on the bottom, and that part, the 1 mole, has to go on top. So 1 mole equals 6.022 times 10 to the 23rd gold atoms. That is going to cause our gold atoms to cancel out. Moles. Do we have to, so here's where you need to think if you need another conversion factor. If we don't have gold atoms anymore, moles is a unit that's left over. Is our final answer going to be in moles? If you're not sure, read your question again. It says calculate the mass of your gold atoms. Is a mole a mass? No, it is not. So what we have to do is get rid of moles and try and get to grams, or your mass, because we said we have to answer in grams. Well, if we look at our conversion factors, we have one thing that has a mole in it, as well as grams. Well, that's pretty good, isn't it? So let's use this conversion factor. We have to make sure that we get rid of mole, so that has to go on the bottom. So 1 mole of gold is 197 grams. Mole will cancel out, leaving grams as our final unit, that would go to the end. Is that what we're looking for? Yes, it is. So we don't need any more conversion factors after this. Now we can go on to the 7th and final step, which is solve. And like I said, we simply have to multiply by the stuff on the top and divide by the stuff on the bottom. Okay, especially if there's ones here. If there's things that were not ones, you'd have to figure out what the entirety of this fraction was before. But in our case, since we only have one, we can just keep going. So let me bring up Desmos again. So we have, remember in Desmos, don't forget to put your little parentheses around stuff. So 3.47 times 10 to the 23rd. And we're going to divide that by 6.022 times 10 to the 23rd. Okay, and we find out that going from here to this conversion factor is 0.57, I believe is what I had on there. I just got rid of it. Undo. There we go. But now we still have to do this part of the conversion. So if we keep going and take our answer, we have to times that by 197 grams. Okay? And we'll find out that we get the answer 113.5. And then we can take our final unit and drag it over here because it's going to the end. And we find out that that is how much that many moles of gold weighs. Read it again. And did we find out what we needed to? Calculate the mass of that many gold atoms. We have answered it in grams. We have, yes, indeed, answered our question. Okay. Sometimes you'll see, like in your first question that we had one conversion factor used. This is a one-step conversion. And in some other cases like this one, you have a two-step conversion where you have two conversion factors that you use to get your answer. Okay? But you have to follow these 7 steps. Okay? Let's try one last one before I end this video, which is calculate the mass of 8.4 moles of iron. So 1. What's important? Mass. 8.4 moles and iron seem all like they're important. 2. What do I need? I need to calculate the mass again, so I need this in grams at the end. 3. What do we have? I have been given 8.4 moles of iron to work with. This is what I have. Do I know anything about iron quite yet? No, they don't tell me quite yet. 4. Look at your relationships. What's the relationship between mass and moles? Not quite sure, but we know that iron has a molar mass, which is in grams per mole, which might help us. I just spelled relationships wrong. Sorry. Five, conversion factors. Well, we know it talks about mass. We need to find it. We talked about iron having a mass. So if we look at iron on the periodic table, you find that it says it has 55.845. So I'm going to round that to 55.8. So the molar mass of iron is 55.8 grams per mole. And just for the heck of it, we know that 1 mole equals 6.022 times 10 to the 23rd. Just because we know that's a conversion factor. Okay? Once you have that, 6, the conversion equation. So I'm going to box off my conversion factors again. So conversion equation, starting with what you have, is we start with 8.4 moles of iron. There's no units to accompany that, so it's all on its own over 1. Now, do we have a conversion? So what we need and what we have, let's look at our relationship again. We have moles of iron. We want to get rid of that. So we have to have moles on the bottom. Okay. And let's see, just we know we need to answer in grams. So is there any one of our conversion factors that can take care of that right away? Well, this one has both mole and grams, so this one's going to take care of it all for us at once. So we know that 1 mole of iron is equal to 55.8 grams. So moles cancels out. We're going to answer in grams. Did we need to find a mass? Yes, we did. So we don't need to write any more conversions. We have a 1-step conversion problem. So all we have to do is solve this. And that's easy enough. So 8.4 times 55.8 should give us 468.7 grams of iron. Oh, I forgot to put 7. Solve. We just kind of did both 6 and 7 at the same time. So, did we need to answer in grams? Yes, we did. We found what we needed. Okay. So hopefully this helps a little bit, these 3 examples of using different things to convert, understanding conversion factors, and how to set up your conversion equation. Okay. using these 7 easy steps. I'm going to keep practicing this over the upcoming week and see where we are, see if we are going to be ready for moving on to TOEIC after this. Okay? So, hang in there, chemistry. We're coming back in class next week. So if you have questions, feel free to ask them while in class, because that can help out a lot, just seeing it in person and not just on a video screen. All right, talk to you later, chemistry. Bye.